So in this video, we are going to finish section 5.1. So if you can turn to your packet where we left off in the last video, and we're going to do kind of the last two examples. So in this video, we're going to talk about sampling distributions and how sampling is a probability experiment. So remember in unit 1, we talked about like randomly collecting samples from people and displaying the data if it's categorical in a frequency table like this one. And if we have that, we can use that table, or even if the data is not in the table, we can use that data to calculate probabilities, the probability that someone would own a house or own a condo. So sampling an individual from a population is a probability experiment. The population is the sample space, and the members of the population are equally likely outcomes. And so when we talk about the total outcomes, that would be the total number of people sampled. And then when we're talking about the outcomes of the event is one of the categories that we have in the table. So for example 3, it says there's 10,000 families in a certain town categorized as follows. A pollster samples a single family from this population. And it says, what is the probability that the sampled family owns a house? And so we're going to find the probability the same way. If we want owns a house, we would take the number that own a house, and we would divide, again, by the total outcomes, which is just the total number of people. And so this probability is the same thing as what we talked about in chapter 1. It's a relative frequency. So relative frequencies are probabilities, and we find it exact same way. So we take how many own a house, which is 4,753, and then we're going to divide by the total. So to get the total, you can add these 4 up, or you can realize they told me that there's 10,000 families in this population, and so that would be your total. And then we would just divide. And we get 0.4753. And you could also leave it as this fraction because that's the simplified fraction, or put it as a decimal. So B says, what is the probability that the sampled family rents? Okay, so when we talk about renting, there's actually 2 options. It says rent a house or it says rent an apartment. And so if I want the probability that they rent, I need to take both events into consideration. And so I'm going to take the number that rent a house and add the number that rent an apartment to get the total number of people that rent. Okay, so I want everyone that fits this category rents, and so I have to add those 2. And then again, I divide by the overall total. So in this case, I'm going to add 912 plus 2857 and put it over 10,000. And if we do that, we get 3,769 over 10,000. And that is equal to 0.3769. Okay, or again, you can leave it as this fraction. So we do finding probabilities a lot for categorical data. And again, it's the same idea as finding the relative frequency. So the last thing in section 5.1 is talking about an unusual event. And unusual events are always something to take note of. Sometimes we get the probability of an unusual event because it's rare, it's really rare, or we made a mistake in the data. And so they're always interesting to look at. And an unusual event is one that's not likely to happen. And there's no hard and fast rule, but the rule of thumb that we are going to use for unusual events is that if the probability of event A is less than 0.05, or you can think of it as 5%, then we consider that the event is unusual. So if they ask you, is the event unusual? You would calculate the probability. If it's less than 0.05, then we say yes. If it's more than 0.05, then we say no. And technically, if it's less than, or if it's equal to 0.05, then we say no. It's supposed to be less than it. So in a college of 5,000 students, 150 are math majors. A student is selected at random and turns out to be a math major. Is that unusual? So we want the probability that someone's a math major. Again, to find that probability, we take the number that are math majors and we divide by the total in our sample or in our 5,000 students. So number of math majors are 150, and then we're going to divide by 5,000. Okay, if we do, we get 0.03. And then again, we compare it to 0.05. So because 0.03 is less than 0.505, we would say yes, the probability of being a math major is unusual. So the probability of being a math major is less than 0.05, so we would consider this event of being a math major as unusual. And so that is all of section 5.1. Again, please make sure you get this probability formula down because we're going to build off of that when we do section 5.2 and 5.3. And then if you have any questions, please let me know in class.